The Lockheed P-38 Lightning was America's first truly modern military aircraft and the first fighter to top 400 miles per hour in level flight. Designed in the late 30s by Kelly Johnson, who would later be famous for creating the SR-71 Blackbird, the P-38 revolutionized the industry with smooth, butt-jointed metal skin, flush riveting, all-metal control surfaces, near speed of sound dive, and a bubble canopy. Its distinctive twin-boom shape also made it the most recognizable of all wartime aircraft, to both friend and foe alike, and pilots considered it the war's first great hot fighter. I'm delighted to welcome you to another Roaring Glory Warbirds program as I take you along to fly Lockheed's famous World War II fighter, the P-38 Lightning. My dad, Irv Ethel, flew the 38 in combat over England and North Africa with the 14th Fighter Group from July 1942 through February 1943, so I've been attached to this airplane ever since I can remember. He found it to be an outstanding gun platform. He got 4 confirmed kills and 1 probable in the air, and that was in a single mission, and another 10 on the ground. Climbing down off the Lightning gives you an idea of just how large this aircraft is, a feature which often led to criticism of its dogfighting potential. No question, it took some time to get skilled in a 38, probably more than what it took in a single-engine fighter. It was more complex with 2 engines, but it was also more versatile. I'll show you some of that today in the air. The Lightning was ideal as both a gunnery platform and a photo recon ship, because everything could be consolidated in the nose. With counter-rotating propellers and no torque, concentrated firepower, twin-engine safety, hydraulically boosted ailerons in the late J&L models, and range, the Lightning was particularly useful in the Mediterranean and Pacific theaters, and it was the mount of America's 2 leading aces, Dick Bong with 40 kills and Tom McGuire with 38 kills. One of the critical things on pre-flighting a P-38 is checking all the intakes, and there are plenty of them. The center intake in the chin scoop is the supercharger intercooler. On either side of that are scoops for the oil coolers. When the air comes through the oil coolers, it exits through these doors, and this flap is controlled by a thermostat, so it regulates the oil temperature. A couple of critical intakes in the back, the carburetor air scoop, and then on each side of the boom, there's a radiator and a scoop. It was so streamlined, it had problems with compressibility. Going so fast in a dive, the controls would become unmovable due to what would later be known as near transonic shock waves moving back across the wings and tail, trapping the ailerons and elevators in an aerial vise. Not until late in the war did production versions have dive recovery flaps under the wings to prevent this problem. The P-38 proved to be the most adaptable of all wartime fighters, able to perform and perform well any number of missions assigned it. The hallmark of the airplane are these massive vertical and horizontal surfaces on the rear of a set of twin booms. The Germans nicknamed it Der Gabelschwanz Teufel, which meant the fork-tailed devil. You can sure see why. Long before the P-51 came along, the P-38 could fly 2,000 miles. It was genuinely America's first long-range fighter. But for pilots to fly it, you had to climb up this small boarding ladder, a unique feature of the P-38. Took a little time to get used to, but with the left foot in the first go, pulling the handle here, putting the right foot into this stirrup, up here, and then there's a handhold, up, push the release button, and it's stowed. When the P-38 first entered combat in the summer of 1942 over the Aleutian Islands in Alaska, it was almost a year ahead of the P-47 and a year and a half ahead of the Merlin-powered P-51. Immediately in demand in every theater of war, it gave the Army Air Forces great hope that we could, at last, meet the Germans and the Japanese on equal or better terms. It was also our first true high-altitude fighter, with turbo superchargers designed by General Electric. Driven by the engine exhaust, these turbos, or turbine wheels, pumped air into the carburetors so the engines could deliver sea-level horsepower at high altitudes. The 38 also had a fine extended span high aspect ratio wing, and it was one of the first aircraft to use tricycle landing gear, which made it far easier to land and take off. So let's find out what it's really like to fly.
The P-38 is complex and confusing compared to later fighters. Many things are simply placed where there's room. Flap and gear handles are on opposite sides of the cockpit. Kind of have to memorize where everything is. The major difference in the P-38 is it had a control wheel right in the middle where a stick would normally be. And my dad said he liked this because he gave both hands on the wheel and muscled the airplane through just about anything, particularly a turn. You could really pull the airplane back. All the engine controls are on the left, throttles and propeller controls and mixtures. So that was easy to manage. But it takes some getting used to. This is a complex airplane. And if the engine fails, one engine or the other fails, you've got to be quick. You've got to understand quickly what's going on and feather the engine and fly away. It was a technique that wasn't particularly difficult, but you had to do it right every time. Early in the 38's history, pilots were killed without even knowing what had happened to them. The airplane would come off the ground. If an engine quit, there was so much power on the other engine, it would roll over and go into the ground. The fuel selectors are a bit confusing on the earlier models. The late models aren't too bad, but they're down to the left of the seat, and you've got to place the detent very firmly. One of the problems was it could get stuck between detents, and that would cause the engines to fail. If one engine fails, you can always feed the fuel from one tank to the other, which is a nice thing, so you can use all the fuel even on one engine. And on one engine, this airplane would cruise at about 255 miles an hour, which is terrific, considering that's about the same cruise as two engines. Took a little more drag, you had a little more to deal with, but it could be done. Starting the airplane's a bit complex, no matter how you get around it. You kind of got to have three hands to do this. Battery on. Crossfeed switch off. In the earlier model airplanes, in this airplane you simply select the reserve tanks because that's what the carburetor vapor return feeds back into. Check operation of the booster pumps, and each tank has a booster pump, so simply selecting the tank gives you the boost pump, and then you turn them on down here at the left. Check the low-level warning lights and the fuel gauges. Bomb selector switch is safe. We don't have any drop tanks today, so it's not a worry. Throttle's cracked, 1/10 to about 3/4 of an inch open. Propeller controls full forward. Switches in constant speed automatic. Before that, propeller switches. Circuit breakers in for the propellers forward of the mixtures. Mixtures at idle cutoff. Oil cooler flap switches in automatic. Generator switch on. Coolant flap override switches off, which basically means they're in automatic. Intercooler flaps open if they're installed. And we're ready to start. Master magneto switch on. Then each engine has a inertia starter and an engage and a prime. For left engine, we push up on the inertia starter. Let it wind up. Push engage and prime. Prime. It fires off and we push the mixture forward. Check the oil pressure. Coming up, looking good. Now we do the same procedure for the second engine. This time we pull the switches back to spin up the inertia starter for the right engine. Pull the engage switch, prime. It starts and we go up on the mixture and it catches. And we check to make sure oil pressure is coming up, looking good. Everything is normal. Now the airplane's running. Warm-up is not too complex. We want to get this thing above 40 degrees centigrade before we do a run-up. So 1200 RPM gives us plenty. And just hold the airplane with the brakes. And we're all set. Now we'll start to taxi. And taxiing the airplane is not a complex operation. Like most of the World War II airplanes that have nose wheel, it does not steer. You just use differential power and a little bit of brake. To make a turn, let's say you want to turn to the left, you push the right engine up on the power, it pulls the airplane around, pull the power back, and push back up on the left engine for power, and it straightens the turn out, and down we go down the taxiway. Fairly simple. It's a beautiful taxiing airplane. This has got about the right feel on the brakes. The pedals are a little high, so you end up wearing your shins out taxiing this thing, and everybody said holding the airplane with brakes or taxiing the brakes was the most exhausting part of flying the airplane. I agree with that. Okay, the airplane is plenty warm now. We've got the coolant almost up to 100 degrees, and we've got a good 50 degrees plus on the oil temperature. So each engine we're up to 2300 RPM. Here we go. Airplane's easy to hold on the brakes. We got 2300. We'll check the mags. Left, both, right, both. It looks good. Cycle the propellers. Go. They work fine. Then we'll check the props in manual position. Decrease. Then back to increase. The same RPM works fine. And pull the power back. Now we do the same procedure for the second engine. We'll check the magnetos, left, both, right, and both. Cycle the propellers, come back, the Curtis Electric propeller just cycled fine. Now we'll check it in manual, flip it to manual, go decrease, a couple hundred RPM, looking good. Now back to increase, manual increase is coming back up, that's fine, and switch it back to automatic, let it stabilize, and bring the power back. Okay, we'll do the pre-takeoff checklist. We've got both windows locked in place. That's very important because the windows create quite a bit of rough air over the tail if they're not up and locked. Propeller levers full forward to increase RPM. Propeller selector switches in automatic. Mixtures in auto rich. And selector valves on the tanks, both on reserve. Controls free. Fuel booster pumps are coming up to emergency. Elevator tab 3 degrees back. Rudder tabs at 0. Now we'll line up on the runway, and we want to make sure the nose wheel is straight, because if you get it cocked and you come up on the power and let go, it will lurch to the side it's pointing. So I'll roll a little bit, test the brakes a little bit, looking good. Okay, now we're holding the brakes. Now we just come smoothly on up to about 30 inches plus. In the manual it says go to 46, but we really don't need that much. Release the brakes, here we go, and then push right on up to 52 inches of manifold pressure. This thing really gets going fast. I mean, this is great acceleration. Before I know it, I'm right at 70. Bring the wheel back at 99. We're flying off at 90, looking good. Everything is looking great. Make sure the RPMs are fine. Up on the gear. Okay, power back to 46 inches, slowly, and 2,600 RPM. Let's climb. Now we're climbing out. It's anywhere from 140 to 180 miles an hour. To tell you the truth, it almost doesn't matter. Anywhere between that and about 200 gives the airplane an excellent climb rate. And as they said in World War II, climbs like a homesick angel, and it does. The climb rate is well over 2,500 feet a minute, and we don't even have the stick any further back than climbing at a normal rate. The great thing on takeoff, there's no torque. It's like a jet. It was an ideal gun platform. You didn't have trim changes with power setting changes. You didn't have trim changes with speed. You could simply pull the nose up or push it down, and nothing changed. You could track beautifully. There isn't near the noise level in here that I expected. Single-engine fighters, you've got those exhaust stacks up front, and they come right back into your ears. Here, the turbos are back behind you, and it's very smooth indeed. This is certainly a Cadillac of an airplane. That's the first surprise. I think I was expecting a little more vibration, a little more noise. It doesn't have it. It's very smooth. The weak point is you can't see out either side down. The engines are truly in the way, and this very long wing sticks out there, so you're stuck. You're going to have to roll the airplane over to see something, which is kind of fun, but it was a liability in combat for being able to keep track of enemy fighters that were near you. Like all Lockheeds, the 38 is smooth with excellent ailerons. Personally, I love the wheel in this thing. With 2 fighter stick grips, one really has a feel like he's got a handful of airplanes. Now we'll try a stall. This is a very docile airplane in the stall. It's absolutely no effort at all. You bring the power back, the nose up, and okay, you're coming back on the speed, and below 100 you can feel it getting a little mushy, but very stable. Again, no torque problems. Your feet are almost on the floor at this. You get a little bit of a shudder, and then the nose just goes forward. And you put the power back on, put the nose down, it flies out of it easily. You can do this in an accelerated stall as well. You can pull the airplane very hard into a bucket, which Bonham and Blair both like to do. They could actually track to 0. You could actually